All right, section 9.6 is translating all conics. So what we're going to do with every section that you cover, we're going to then turn around and we're going to translate whatever conic you talked about. So section 9.2 talked about parabolas, and then in 9.6 it's also going to talk about parabolas, but it's going to translate them. Okay, so for example, in 9.2 you had parabolas that were all centered at the origin, you know, opening to the right or to the left or up or down. Now we're going to take those and we're going to translate them. So for example, maybe the one here centered at the origin is going to shift to the right 3 units, right? Maybe this one opening to the right is going to shift to the left 2 units and down 2 units. So it's going to look, you know, something like this. So basically these are going to be translating. Everything that you learned in section 9.2, however, stays the same. So these are the equations that you should familiarize yourself with, and I would pause the video for sure and jot these down, because remember, you get to use your notes when you take your test. So standard form for the equation of a translated parabola, and note that HK is the vertex, and HK should not be anything new to you. However, you note that H is always the opposite sign and K usually was not. With parabolas in the conic form, both H and K, notice, are subtracted, so they both will be opposite sign. So if you have a horizontal parabola, you know that your y is squared, still going to be squared. However, it's going to be y minus, plus or minus something, and that K value tells you where you're going to translate in the y direction. And the H, which of course you know is vertical, and the H is connected to the X, so that's going to tell you where you're going to shift in the X direction, so in other words, horizontally. And notice you still have the 4p in front of that, and remind yourself that P is the distance from the vertex. And I'm going to say now, or remind you, I guess, it's the distance from the vertex, but remind yourself now that the vertex is going to be at HK and not 0, 0. Then, of course, same thing with a vertical axis parabola. The x is squared, but it's going to be minus h, and the y is still minus k. So notice the k is always with the y, the h is always with the x, whether it's squared or not. And then the 4p is always in front of the piece that's not being squared. So the first thing I want to just make sure that you recognize when a parabola is or is not in standard form. So note that this is standard form, and we want this equation to be in standard form. So you want to isolate the quantity squared, and these actually get much worse when you get to pre-calculus. We'll keep it pretty basic for you, quite honestly, in this section. So if I want, again, this to look like this, that already does. But then I want it to equal everything. So I'm going to get all the rest of the stuff over to the right-hand side. So I'm going to subtract the 8x and minus the 8 over to the other side. Okay, then note, that I have a 4p and then a parenthesis. Well, I don't have a parenthesis here, so I'm going to factor out what I can. And obviously I can factor out an 8 or a negative 8, and I'm going to take out a negative 8, probably for obvious reasons, so that my x will be positive. So x plus 1, that will leave me with. And note then, it's in standard form, so I have the y minus something squared, my 4p would be equivalent to negative 8, I have my x and my h all in parentheses. And then just a side note, I mean, this is all I really asked you to do in this problem, is to write it in standard form, and that is done. But if I wanted to figure out what P was, well, first my vertex is HK. So H is negative 1, that's by the X. K is positive 2, and that is my vertex. And P, I know 4P has to be equivalent to negative 8, so P is clearly negative 2. And I'll elaborate that on that next. Okay, so note this problem says to write an equation of the parabola whose vertex is at 2, 1 and whose focus point is at 5, 1. And I'm actually, it does not say anything about graphing it, but I'm going to graph 2, 1 and 5, 1 because I just want you to think about this. So over on my graph, I'm going to graph 2, 1 and 5, 1. Okay, and then I'm going to kind of make that smaller again, just so that those points, you can still see those points. So I know that my vertex is at 2, 1, and my focus point is at 5, 1. So 2, 1 is my vertex, and my focus is 5, 1. So remind yourself that the focus point is always inside a parabola. So if my vertex is here, my focus is here, my parabola has to open to the right to encompass that focus point. It can't open up or down or to the left, because then that focus point won't be contained. So I'm just going to sketch this. I don't really care how wide or narrow it is. But I do now know, based off of this information, that I have a horizontal parabola. So it's going to be this equation. It is not centered at the origin, so I've got some shifts in there. Okay, so I can eliminate this one. Now, you do not have to graph this, so you can also note the points have the same y value, 2, 1 and 5, 1. Hence, they are going to be, since they have the same y value, they're going to be a horizontal parabola. If they had had the same x values, they'd be vertical parabolas, so that's always something that might help you out. But I know my vertex is hk, so h is going to be 2 and k is going to be 1. Okay, and the distance between my vertex and my focus point happens to be 3 units. And I can just count that, 1, 2, 3, but I can also see from 2 to 5 is a distance of 3. So that means P is going to be 3. So again, I can't stress to you enough, P is the distance from your vertex to your focus point, 3 units. And it's going to the right, so it's positive. If it were going to the left, my focus point would be to the left, hence P would be negative. Okay, so now looking at this, I know H and K, and I know P, so I really can just write my equation, and that's that. So y minus k, and k is 1, so that's 1, quantity squared, equals 4p, and p is 3, times quantity x minus h, and h is 2, and then of course simplify this. And don't distribute that 12 through, just kind of keep everything all nice and in standard form. And there's your standard form parabola that represents the situation. All right, I'll go through this one quicker. Write an equation of a parabola whose vertex is at -3, -1, and focus is at -3, +1. So note that the x-coordinates are the same, so I should have a vertical parabola. If you're a visual person, and I definitely am, you can plot -3, -1, and you could plot -3, +1, and you know that the vertex is here, is the -3, -1, and you have to encompass the focus point. So your parabola has to be vertical, and it has to be opening up. So it's got to be x squared. So I'm going to use this one because it's vertical. And the distance between my focus point and my vertex is 1, 2 units, and I can see here between -1 and +1 is 2 units. So, and it's opening up, so I know it's going to be +2, so P is 2. So again, I can write my equation. So x minus, you know what, this is wrong. I'm sorry, this is h and this is k. I mixed up my h and k values, I apologize. So x minus h, which would be a +3, quantity squared, equals 4p, and I know p is 2, times y minus k, and k is, this is my h and k, right? K is +1 then, and simplify 4 times 2 to be 8. And there is my equation of my vertical parabola opening up. Okay, last one says, write the standard form equation if I know the directrix is -2 and the vertex is at 3, 1. So again, if you're a visual person, and I am, I might plot the point 3, 1, I know that's my vertex, and my directrix line is going to be y equals -2, which would be right here. So remind yourself that your directrix line is always outside of your parabola. So if my vertex is here, I want to open up, because my directrix line will always be perpendicular to the axis of symmetry and never inside or crossing through my parabola. So I know that my directrix line is how far away from my vertex. Well, my vertex is up 1 unit, my directrix line is down 2 units, so that's a distance of 1, 2, 3 units. So I know that P is going to be 3 units. Now it's +3 because my directrix, or excuse me, my focus point is going to be 3 units above encompassed in my parabola, because my directrix line is below it 3 units, my focus point is above it 3 units. So P is 3. I also know it's a vertical, so I know it's going to be x minus h squared, because it's vertical, equals 4p times y minus k. And I know P is 3, and I know my hk from my vertex, so I just plug everything in. And again, I know P is 3, and I know k is 1. And I simplify, of course, you know 4 times 3 is 12. And there's the equation that has the following information. One last thing, if I gave you this equation and asked you to graph it, it should be pretty easy to pick out that the vertex is 3, 1. So you would plot that point. You know it's vertical because the x is squared. You could solve, you know, 4p equals 12, so that p would have to be 3. So then you know the focus point, because p is 3 units above your vertex. You'd plot that. Your directrix line is 3 units below your vertex. And then you would test a few points, and these get a little messier in terms of testing points. So, you know, I might test, I don't know, let's see, probably I would test maybe, yuck, it's hard to tell. I would probably test maybe 4 for x. And if I put 4 in, 4 minus 3 is 1, 1 squared is 1. Then I would divide by 12, so I'd have 1/12 plus 1, which would be 1 and 1/12. Not ideal, but I could at least estimate that. So I know when I would go over to 4, I'd go up 1 and 1/12, and then of course reflect that. And right there I could see that it's a pretty wide parabola. And really you don't have to test a ton of points as long as you get an idea for the width of that parabola.